Hey, this is Don once again, owner and principal Padlock Technologies, here to do a brief comparison of distant vector versus link state protocols. Um, which one is better? Which one should you use, in my personal opinion? Use cases and, just basic comparison. Now, I will preface this. It really depends on what you like doing, but there are certain situations where a distant vector protocol is better than a link state protocol, especially when you're talking about things like OSPF, ISIS versus EIGRP. I'm not going to say RIP, because if you're using RIP in your environment, you're crazy, for one. And I'm not going to say IGRP because that's been deprecated and nobody's using that. So distant vector, let's go to the board here. And we're going to say distance vector, totally spelled that wrong, but whatever, versus link state. So distance vector versus link state, very simple conversation here. The difference between distant vector protocols and link state protocols, I'm just going to give some comparisons because we could be here for days. So distant vector is routing by rumor. So basically, this is just reachability information only. Reachability information. That's it. It's not topology information. I don't really know what's going on in the other networks, or I don't even know what's really going on to any other network other than me. And I only know very, very little. Just reachability information. That's it. Link state protocols is reachability and topology information. Now that topology information, let's say with OSPF, it would be within an area, right? And then for ISIS is within the level, and technically area as well, right? So because there are areas in ISIS too, but it's really in the net, or the network identifier entity, or just say net. But it's similar to OSPF in terms of areas, and different areas, obviously, you'll start having level 2s and level 1s versus ABR. So the same vernacular a little bit between ISIS and OSPF. You just got to know the terminology per se. ISIS is really in the service provider network, but if you look at some of the protocols or some of the technologies that are coming out, like ACI, like SDA, they use ISIS under the hood if you do automation. So the other thing, the difference is summarization can be done in distant vector protocols anywhere in the network. So summarization anywhere, right? In link state protocols and OSPF, you can only summarize in 2 areas, right? You can summarize at the ABR, and that's going from whatever area in area 0, and then you can summarize at the ASBR, and this would be something like, well, I would say you can use NSSAs, and you would do the redistribution at the ASBR, right? You can't redistribute anywhere in the network other than those 2. That's why if you're doing something like DMVPN or FlexVPN, they tell you to use distant vector protocols because you can summarize anywhere in the network. With link state protocols, and I'm just going to use OSPF for now because ISIS has its own little tricky stuff to it, and I don't want to get into that conversation. We can compare OSPF to ISIS later. But let's say if you're doing DVPN with OSPF, certain things you got to worry about. First thing you have to worry about is summarization. You have to worry about that, right? You have to worry about DR, BDR elections, right? You got to make sure you stop that from happening, right? Because you don't want a spoke to become the DR, right? Or the BDR. You don't want the spoke to do any of that. So now you have to manipulate OSPF priorities, or you have to use like point to multi-point as network type to avoid this here, right? And potentially getting, adjacencies with a spoke. And if that spoke goes down, kind of blows up your whole DMVPN architecture, right? The other thing from a route manipulation standpoint, it's a lot easier to do it in distant vector protocol. So route manipulation, right? Route manipulation. Now, pro and link state protocols that you don't see in distant vector protocols, and where you would use this at is if you were doing something like MPLS TE or MPLS SR TE, which is segment routing, which is basically a technique that eliminates LDP because the label is carried in IGP. So it's carried there, so you don't have to run LDP on top of this, right? You can just run segment routing, and then you have your prefix SID versus your adjacency SID. It's just a different way of doing MPLS, right? This MPLS technique as a whole. Where should you implement this? So we also have a benefit is where, issues in one area. So issues in one area don't propagate to the other area. So routing issues in one area doesn't affect another area. All right. So if you have something going on, some funky thing going on in area 1, it doesn't affect area 2, right? Limitations of, say, OSPF is everything got to be connected to area 0. There is no area 0 in distant vector protocols in EIGRP. There's no such thing as an area anything. Now, with that being said, though, things like EIGRP have this ugly thing called SIA, or stuck inactive, right? And if you ever got burned by this, you know what this is. So this is, if I lose a route to a destination, I'm going to send out a query called SIA query to see if anybody else has the route. And then I'm going to wait for a response from everybody, right? And if that response takes forever to get back, it's going to cause convergent issues and stuff like that. Now, the way to get around that is to use stub feature or summarization. All right, you can get around that by doing that, right? There's race condition issues that you have to worry about on top of that with distant vector protocols that you don't have in link state protocols. The complexity of multiple areas, and this is kind of a design issue, can really burn you when it comes to OSPF. If you don't design your areas correctly, you can have a problem. If you forget to put 2 different areas and have them connected to area 0, and you do something as crazy as area 1 is connected to area 2, which is connected to area 0, now you have to do something called a virtual link. And that virtual link will simulate area 0 between the 2 to get to fix that. Big problem. That's why you got to make sure from a design perspective that you build out OSPF or any link state protocol correctly. Now in the ISIS, there's only level 1 and level 2. And if you think of ISIS as just a bunch of NSSA, right? So if you're a level 2 router and you connect to a level 1, if you're a level 1 and 2 router and you connect to a level 1 router, in that area, you will only get a default route when you're trying to get out. You do not learn anything from a inter-area route like you would do in OSPF. That would be a, type 3 route, right? So your 1 and 2s is going to be a router. Then you have your network, or let's say LSA standpoint. Let me use the correct vernacular here. So you have your type 1 LSAs and your type 2 LSAs, which is basically your network LSA. Then type 3 LSAs is your network summary LSA, which is generated by the ABR. Then you have your ASBR LSA, which is generated by the ABR. That's a type 4 LSA. Then it's a type 5 LSA, that's an external. Then a type 6, which nobody uses, which is like I think it's some kind of deprecated group LSA. Don't quote me on that top of my head because nobody uses a type 6. And there's your type 7 LSA, which is coming from your NSSA when you redistribute internal routes. That gets converted to a type 5, which is a type 5 external route. And it gets translated by the ASBR and then goes into area 0. So that's the LSA stuff, right? But when in ISIS, you don't have that. You basically have it's called a PDU, sorry. And when you hook up a level 1 and 2 router to a level 1 router, that level 1 router will only get a default route. And it basically just says, hey, go to the ABR or ASBR if you want to call it that, but go to the ABR to get out to the network. All right? That's all again. Now, the ISIS is pretty simple to implement. It's a lot easier to update as well. Like OSPF compared to ISIS, when they did IPv6, you just wrote a TLV, right? ISIS has TLVs that you can write without actually writing a new protocol. Whereas OSPF, you got to write a whole new protocol for it, which is why IPv6 has it's OSPF v3 versus OSPF v2. In ISIS is just multi-topology. So it's IPv4, and then when you go in unaddressed family IPv6, you type multi-topology. Now you have to do a wide metric for that to get that to work, but you do wide metrics, and now you can do IPv6 and IPv4 in the same protocol, or in the same routing instance. With OSPF v3, it's a whole new protocol for IPv6, right? So back to distant vector protocols, though. If you want ease of summarization and ease of, configuration, don't have to worry about all this other stuff that comes with designing, then go with distant vector. If you are trying to do something like MPLS and everybody needs to know the metrics of everything in that area, then you need to go distant vector. Link state protocols are the way to go if you're going to do MPLS or MPLS TE or MPLS SRTE. You need to make sure that you use a link state protocol for that, right? Because everybody has to know everything in the network in order for you to do traffic engineering. So that was a brief discussion, a brief comparison on distant vector protocols versus link state protocols, when you would use them, why you would use them, some of the things that you need to look out for. Hopefully this video was informative. Thank you and have a nice day.